We're talking about lists, what they are, and some special things about them, right? So the first thing is, what does the list look like, right? So a list is signified by these two brackets, right? So I just made an empty list. So A is the empty list right here. And just to prove it to you, this is of type list, right? And two very important things are lists are a compound data type, data structure, and they are mutable, right? So what do I mean by these two things? They are a compound data structure because I could put multiple data types in them. So here I'm going to put an int, then I'm going to put hello, then I'm going to put none, right? I can't type. Right, so here I have an int, a str, and none type. Perfectly fine, no errors thrown. This is still going to be a type list. So that's what I mean by they are a compound data structure. And just like strings, so if we had for car in hello, and we could print car, right? This would just print every character. So strings are iterable. We could go into H, E, L, L, O, right? We could do the same thing with lists, right? We could 1, 2, high, true, right? Compound data structure, holds multiple types, and let's just call this element, right? And once again, this could be any variable. I just like to be descriptive. And boom, right? So lists are iterable as well. And what do I mean by they are mutable? They are mutable because I can change things inside them. And we've heard this term before in immutable, right? Strings are immutable. Just a recap of that, if I have hello, right? If I try to change the 0th index, which is H, to J, to make jello, this is going to give me an error, right? So stir object does not support item assignment. So strings are immutable. I can't go into hello and change one of its characters. On the flip side, however, if I have 1, 2, 3, A is now a list, and I want to change index 2 to 4, right? So what position is index 2? It's where 3 is. So 0, 1, 2. Remember, we start at 0. So if I do this, let's change this to 4 because we wouldn't see any change if I did 3. If I did that and I say A, 1, 2, 4, I changed 3 to 4 with this line right here. So that's what I mean by strings are immutable. And also, strings have very cool methods that we can do. So if I had 1, 2, 3. Well, before we talk about methods, there's one other thing. I can concatenate lists together, right? So if I wanted to make this 1, 2, 3, 4, right? I could say, remember we read the right side first and assign it to the left side. So A at this point is 1, 2, 3, and I want to add 4 to it, right? So if I say print A right here, it's going to show me 1, 2, 3, 4. And notice I had these brackets around it because I had to make this a list of 4, because this addition sign right here only works when you have 2 lists together. Now if you see, if I took out this is going to throw me an error saying can only concatenate list, which is an A, to list, not int. So 4 is an int. So remember, if you're doing it this way, to include these brackets. And a shorthand way of doing this would just be A plus equals 4. Right? So what if I don't want to have to add brackets to everything that I'm adding, right? Because this takes a long time, for me at least. Right? So do 1, 2, 3. And a cool list method is the dot append, right? So this, I don't need the brackets. I could just put 4 in here, and this, what this would do is the same thing as we have above. It would add 4 to this list. So here, this one was from this print statement, and down here we get 1, 2, 3, 4. Same exact output. And now you're wondering, why didn't I reassign A to this, right? Because when we have strings, right, we usually have to reassign things, right? If I go down here, go a equals hello, and I want to make a equals hello all uppercase, right? I would have to reassign it. Boom, right? And if I didn't reassign it, it would give it wouldn't change a, right? So this goes back to mutability and immutability, right? So since strings are immutable, right, this won't change what a is, because once again, as we saw up here, we can't change a. But what this does is creates a new string with the version of a uppercase. So I could just simply reassign it. Once again, this is all because strings are immutable, right? But since lists are mutable, right, I can just call this method and it will physically change a, right? And because of this fact, because we don't have to create a new copy, it could physically change what a is, we don't have to reassign it. And in fact, if we do reassign it, you're going to see something weird. You're going to see that a is now none, right? So what happened here? What this did was say change a to be 1, 2, 3, 4. So right now a looks something like this. But since dot append returned none, when I reassign it to a, what is a now? None. So this is really important. This is probably going to show up on your test that list methods for the most part return none. Right? And let's talk about some other list methods. So I'm just going to create a new shell. Getting crowded. So another list method that we have is the remove method, right? And this just is pretty self-explanatory. So I could remove 4 from a, right? And then once again, a was 1, 2, 3, 4. And what this is going to do is just going to give us back our original list. So here we appended 4, here we removed it, right? And just another quick thing that might be on your test. What if I try to remove something that's not in the list? What do you think is going to happen? It's going to say list.remove x, this is the parameter, and we gave it the argument 5. So you could say 5 not in the list. So it's going to throw an error. So just keep watch for that, right? And we have some other methods I'll just go through. This is a cool one. This is actually a string method that you can use with a list. So what do I mean by that? Let's say we have this list. Hello, my name is Damien, right? So let's say we have this list, right? And this looks kind of like a sentence, except for the fact that these strings are separated and they're by themselves, right? What if I want to make this a sentence, right? You could do a string, right? So this is a string of a space, dot join of a, and when I print a, what do you think is going to happen? Oh, so what happened here, right? This code didn't even execute because of this error, right? Because the error stops the entire code. So let's just remove this to get rid of that error. Right. Hello, my name is Damien. So dot join, this is a cool method. So you call it on a string, and what it does, it says take the contents in this list, which is a, and just put this string in between them. So I chose to put a space here because I want a sentence. So hello, space, my, space, name, space, and so on. If I put a 1 here, what do you think is going to happen? It's just going to put a 1 in between every element, right? So this is a cool method, right? And once again, that's a string method because you're calling it on either the string of 1 or the string of the space, right? So this next part is alias versus cloning, right? Most students have trouble with this, but we're going to make it easy right now. So alias and cloning, right? The example that we like to give is let's say you have Peter Parker and you have Spider-Man, right? If Spider-Man broke his leg or something, would Peter Parker break his leg as well? Yes, right? Because Spider-Man is an alias of Peter Parker. So anything that happens to him also happens to Spider-Man. Now let's say we're in like year 3000 or something, and we could clone people. And I cloned Peter Parker to be some other dude, right? If Peter Parker breaks his leg, right? Although the other dude looks a lot like Peter Parker, his leg does not break. So they're kind of separate. So that's like the basis of alias versus cloning. So versus, let's use that, right? So let's relate this to list. 2, 3, B equals A. So I denote that B is an alias by saying B simply is assigned to A, which is a list, right? So let's print A and print B, right? What's going to happen here? Say print A is 1, 2, 3, and B, I assigned it A, so that's all good. Everyone's good with that. However, let's say before I print A and B, A dot append 4. And now we know that we don't need to reassign this, because if we did, A would be none, and we don't want that, right? But let's say A dot append 4. So now A, this is simple. We think that A is going to be 1, 2, 3, 4. But what about B, right? Think about what I said. Aliasing, right? Peter Parker breaks his leg, Spider-Man's going to break his leg. A is appending 4, B is going to append 4. 1, 2, 3, 4. That's good, right? And then same thing here. If I could append 5 to B, it's also going to append 5 to A. So that's aliasing. And on the flip side, right, let's say B is a clone. Right? I denote clones by these brackets, right? So it's just basically slicing the whole list. So this means that B is a clone of A. So if I append 4 to A, right, we know that A is going to have 4, right? But what about B? Do you think B is going to? No. Using the Peter Parker analogy, no. So what happened here? I said A dot append 4, so A is going to be 1, 2, 3, 4, right? And B, right, B starts off the same as A because we cloned it. And then when we appended 5 to B, it's going to have a 5, not a 4. So when I print A, it's going to give me that. B is going to give me that. And this cloning stuff made me realize that since this is kind of like taking a slice of A, the entire thing of A, you can also list slice, and just like we have strings, so 4. And it works the exact same way, actually. So if I have this, A equals that, and I want to take just 3 and 4, then what I would do, just like strings, 0, 1, 2, right? 2 is inclusive, right? Because it's the start. And you go to the end, what is this going to give me? 3 and 4. So it's the same way as string slicing, you just apply it to list. Okay, now back to aliasing versus cloning. So we know how aliasing works, we know how cloning works. If you do something to an alias, it reflects in both A and B. If you do something to a clone, only things that happen to A happen to A, right? So 4, and same thing for B. Now this kind of gets tricky with nested list. So this is the only exception to that cloning rule. So before I said anything that happens to a clone does not happen to the original, but let's say we have this, right? 1, 2, 3, and then this nested list of 4 and 5, right? So what's the length of this? This is 1, 2, 3, 4, right? So this counts as one element, right? Let's say I do B equals A, and once again, this signifies that it's a clone, right? For the most part, things that happen to A don't happen to B. So if I do A dot append 9, right, and I print A, and I print B, A is going to have 999, B is not, right? that just works fine. That's just like what cloning is. However, let's say we're always going to print A and B. Let's say I do A at this index where the nested list is, so it's 0, 1, 2, 3. A at 3 dot append 12. What's going to happen here? It's going to say, give me what's at A of 3 and what's at A of 3, 4, 5, right? So this is a list, so I could call dot append on that, right? Because it's going to give me 4, 5, which is a list, dot append 12, right? So what's going to happen here, right? We think that it's only going to happen at A because it's a clone. However, I kind of lied to you in saying clones are completely separate, because it's not the case for nested list, right? So if I clone something that has a nested list, any changes to that specific nested list is seen in the clone, so, right? So once again, I appended 99, but this is the big list, right? This is the outer list, so B doesn't reflect that change, as we saw, right? However, when I append 12 to inside the outer list and into the nested list, right, 4, 5, I added 12 to that. B also shows that. So that's the one thing about aliasing and cloning, that when you clone, anything in the nested list is shown everywhere. Note that I said any changes inside this nested list is shown within all the clones, right? But a lot of students get confused when I say A3 equals 5, right? So what am I doing here? I'm saying A3.append 12, so at this point, both A and B have the nested list 4, 5, 12, right? But if I go in here and say A3, right, 0, 1, 2, 3, I'm going to make this entire thing 5, right? So a lot of people get confused thinking that, oh, B is going to show that too because this was the position of the nested list. But no, right? When we say that changes inside the nested list are shown throughout the clones, we literally mean inside. So that means any changes saying like add on 6 here or remove 5 here, right? This is not changing things inside the nested list. This is changing something about the outer list as a whole, right? So let's see this. Right? So we went down here, we appended 99, right? That only happens in A because this is appending it to the outer list, right? And B is a clone. A3, we see that it's 4, 5, and we append 12, right? Since this is inside of a nested list, we're adding 12 to that nested list. Both A and B show that, right? So B, you see, which was we printed second, has 12, right? Because even though it's a clone, we're doing something inside of a nested list. Now here, we're saying A3, the position at A3, right? Which is 0, 1, 2, 3, is now 5. Once again, this is really important. We're not changing things inside the nested list, we're changing the things inside the outer list. And as we know that in cloning, if we change things in the outer list, it doesn't change the clone, which we can see here. So it's subtle but really important. So let's get an example going, right? So here I have something similar, right? A equals 1, 2, 3, comma, 4, 5. So this is one element. B equals A, so B is an alias. C equals B with the brackets and colons slicing of it. So that's a clone, right? So alias and clone. So this is how I would walk through it in a test. I would say this is an alias, this is a clone, right? And we have some code here. B dot append 6, A dot remove 6, C3 dot append 6, A dot remove 1, right? So I highly urge you to do this on the test. It makes your life easier so much, right? So here what I would do is have my starting state, right? So here we have A and B are aliases, right? Because there's no brackets here. So I'm going to say in the beginning, what's A? 1, 2, 3, comma, 4, 5. So this is a nested list, right? And I'm going to say A points to this list, right? So this exact list. And then since B is an alias of A, this is absolute. Anything that happens to A happens to B. So I'm going to point this to the same list, right? So what this does is save me some time. Instead of writing a whole new list for B and having to remember on the test that, oh, B is a clone of, B is an alias of A, so they have to be the same. How about I keep track of one list and point them both to that list. So any changes I make here, both of them reflect, right? And then in the start, C is a clone of B. So as of right now, they look kind of very similar. So C is 1, 2, 3, 4, 5, right, with this nested list. So I'm going to point this to a separate list. Once again, I'm pointing this to a separate list because if I change this one, not necessarily will I change C. However, this is the main part right here. I created a connection between these two nested lists, right? Since C is a clone of B, any changes in the nested list reflect in each other. So what I would do on the test is have this connection right here to signify if I change this, it'll also change this one right here. So let's walk through how I would do this, right? B.append 6, right? So once again, I look here, look at my previous state, right? And I append 6 to B, right? So I append this 6, and note that this is not inside this nested list. It's physically in the outer one, right? I appended 6, right? And look, this already, we see the benefit of this. I don't have to go and remember, oh, A is an alias of B. I have to change that too because it's already here, right? A.remove 6, right? So I look at A, I find A in my drawing, follow the arrow and say, okay, well, this is the previous. So I follow my arrow and say, remove 6. Boom, 6 is gone. And look, B shows that as well, right? And here's where this connection is really important. I say C at 3. So what's C at 3? C at 3 is 0, 1, 2, 3, 4, 5. Okay, so we know something weird's about to happen, right? I'm going to append 6 to this specific thing here. So I go down. I say C, append this 6, right? Oh, but look, I have a connection. I have a connection here, right? We have the connection. So we make the 6 in here as well. So once again, these lines and arrows just makes you remember what to change, right? And note that how when I append 6 here, this is different than appending the 6 here, because this is appending it to the entire list, so it's outside this nested list. But here, what am I appending it to? Not C, but C at 3, which is this one, and the change is reflected in both A, B, and C, right? So I do A.remove 1, A, get A, right? A, follow its line, say, okay, this is the list, remove 1, and boom, it's 1's not there. Once again, I'm just keep reiterating, B shows that as well. And since there's no connection between that one and this one, C is the same, right? So once again, I highly recommend to do these arrows. It makes it so easy. And just to prove that this is what it is, let's type this out. B equals A, C equals B, boom, B.append 6, A.remove 6, C at 3 append, right? A.remove 1. And hopefully this is going to show me what we said. And I think it does. So A, B, same thing. You see, so this connection did hold that 2, 3, and then 4, 5, 6. Boom. And C is 1, 2, 3, 4, 5, 6, right? So I would say this is the most tricky things with lists, and that's basically it for this topic. And there's just some few takeaways that I want you to remember. Lists are mutable. Then what does that mean? You can change the contents inside. Change the contents inside them. And that also implies that list methods return none, right? don't reassign, because if you reassign, that's going to give you none, right? And then remove. Don't reassign. Another thing is, I feel like this is, most people forget this, right? List methods return none. So on the table, if I give you 1, 2, 3, dot append 4, and it says, the two columns value and type, what are you going to give me? You're going to give me value to be none, type to be none type. Once again, note the spelling of none type, lower capital N, capital T, right? You would give me that. And then alias versus cloning, nested list changes show in both aliases and clones, right? And we went over that just now. So I feel like these are really important things. Lists are mutable. You can change the constants inside them, right? So a equals 1, 2, 3. Add 0 equals 0. A 0, 2, 3. Mutable, right? You change the constants inside them. A equals. And list methods return none. So if I do a dot equals a dot append 4, yes, it did append 4, right, to a. So at this point, a is 1, 2, 3, 4. But since this returned none, what's the value of a? I'm going to say what's the type. It's no longer a list. It's a type none type because a is none because it's returned none, right? And we just went over the example in both alias and cloning, right? So good luck, and it's not that hard. Just keep these facts in mind, especially with alias versus cloning. And thank you.